Hi, I'm Taylor with More Than a Teacher, and I'm going to show you how to do a combination problem like this on the SAT. Now typically when people see a problem like this, they start going through all the algebra they would usually need to solve this problem. And if you're like most students, you've been taught in algebra that you solve for variables individually. Now here what we're looking for is a very unique kind of equation. They want us to solve for x squared z minus xyz. And again, typically most students are going to try to solve for these variables individually and then combine them in the way they ask to get the answer. But on the SAT, you don't typically want to split things up unless you absolutely have to. And on some problems, you can't split things up. So you want to try to solve for as many things together as possible. So that's what we're going to do here. Now sometimes you add, you subtract equations that are given like this. But as a rule, if they give you multiple equations and then ask you for a third one or a fourth one, you're just going to have to combine whatever equations they gave you to get what you need. So in this case, adding and subtracting is not going to get us where we need to go because although we have an x here and an x here, adding and subtracting x will never get us x squared. So the way that we know that we're going to have to combine these two equations to get the one we want down here is by multiplying. X times x will give us the x squared that we need, and that's going to then go ahead and flow to the rest of the problem. So if we were to combine the two equations, and we were to distribute xz into x, xz times x would give us x squared z. If we were to distribute xz and negative y, it would give us negative xyz. And that's exactly what they're asking for in this problem. So we already know what x minus y is. They gave that to us. X minus y was 7. And we already know what xz is. They gave that to us as well. That's 5. So if what we want is the product of 7 and 5, then the answer choice needs to be 35. And that's what we would get for this. And that saves you time by not forcing you to solve for all the variables separately. Plus on an equation like this, if you don't have a variable per, if you don't have an equation per variable, there's no way to solve for those variables individually anyway.